Hey, first of all, I want to thank you all for your support here on Patreon. Without it, I wouldn't be able to continue making these tutorials. And here's a little Patreon special tutorial about flex fluids and a tiny bit of GLSL. I haven't done them in what seems like forever, so let's start. Let's start by making a basic fluid sim setup. Add an add sub, add a point, and convert it into a particle. Append it with an actor comp and throw in the NVIDIA Flex solver. Go to the actor settings, enable instancing. We need some initial points. Let's use a sphere sub, plug it into a transform, and append it with a sprinkle sub. I think we're gonna be fine with 10,000 points. Also set the sphere size to be 0.5. Add a null, use it as a translate operator on the instancing page, and set channels for the X, Y, and Z axis. Go to the solver, click init. Yeah, the points are there, but we need a constant mat to see them better. So let's define the boundaries. Add a box sub. You see it goes from minus 0.5 to 0.5 in each direction, and it will be easier for us if it goes from minus 1 to 1. So let's set the scale to 2. Append it with a null, go to the solver, enable boundaries, and drag that null into the bounding box subfield. Let's clean everything up. Add a keyboard and chop. Set the keys to 1 and 2 and use these channels to control the init and start buttons on the solver. It's just easier that way. Add a camera and a render top. Add a null and a transform top. I just use it to get the black background. There you go. Cool. First of all, I want to set the point radius to something lower, like 0.6. Second of all, we need point positions. Let's add NVIDIA Flex top, drag the actor onto it, add a GLSL top. Also, we're gonna need velocity values, so duplicate the flex top and select velocity from the drop down. Nice. Append the GLSL top with the null, and now we are ready to write some code. So first thing you want to do is to uncomment this line, get rid of this line, let's rename the variable to pose and use it for the output. We're just sampling these values and output them. Let's sample velocity as well. Duplicate the line, rename the variable to val, and set the input index to 1. What we can do now is to use another image, like a noise stop. Pretty similar to how you would use a vector field. Increase the resolution. I'm not going to compute any vector fields here, rather just use these raw values. Now we need to get the UV values for the noise stop, so that each particle could sample from the noise texture based on its position in space. So add a vec2 variable, call it UV, and it should be equal to pose xz. That's because we're gonna work with the xz plane, and to remap position values from -1 to 1 range into 0 to 1, which is normally our UVs, we're just gonna add 1 and divide it by 2. Also, don't forget the brackets. Duplicate this line again. And instead of using the standard vv.st, we're now going to use our own UV values. Let's output the force. So what happens now is each particle goes through the texture based on its x and z position, and it samples a value from the texture. Now instead of outputting the force on its own, we'll increase the y value of the velocity by the y value of the force. In this particular case, you can use any channel of the force, they are all kind of the same, and output val. Now use this null as a velocity feedback top in the actors comp parameters. You might remember that the velocity feedback top should be 32-bit float RGB And what we have here is RGBA, so instead of fixing it in the GLSL top, I'm just gonna use another transform top and set it to 32-bit float RGB. Everything goes crazy. The first reason for that is that our noise has an offset of 0.5, so set it to 0. We can just multiply the force by, let's say, 0.1. Yeah, 0.1 is a bit too low. Let's actually use a uniform. Well, we're gonna name it factor, multiply the force by the factor, and now if we go to the vector tab of the GLSL top and add a factor uniform, we can actually control the force. Now you can adjust the noise top to your liking and maybe animate it in the Z-axis. I want to make this fluid audio-reactive, so drop an audio file in chop. If you want to hear it, you can use an audio device out. I guess you already know it, but for now I'm just going to disable it. Let's go basic. Add a math chop, set combined channels to average, then put it through an audio spectrum chop, boost high frequencies to 1. It has way more samples than we need, so let's resample it with the resample chop. First, disable times lines, select new rate, new interval, absolute, and I think 100 samples should be fine. Almost 6K. Oh, it's because here we need to use samples instead of seconds. Now you can convert it into a top. And we can use a lookup to sort of remap these frequency values onto the noise we have. Or any other image, like a ramp, but I'm just gonna stick with noise for this one. Set the noise top to 32-bit float for the negative values, and maybe set the amplitude to 1. Connect the lookup into the GLSL top instead of the noise, and set the factor value all the way to 1. Now you can dial in your noise. It's already reacting to the audio, but maybe you want to do an extra step of setting the colors for our particles. It would be easier if we could have the force values in another buffer. Let's add one. Go to our code, write layout, brackets. Here we need to specify the location. Our original frag colors index is 0, so here we'll go with 1. And now just say out vec4 frag color 1. Now we need to put some values into it. So do the frag color 1 equals td output swizzle, and let's output the force. Now go to the GLSL settings, set the number of buffers to 2, and use a render select top to get the second buffer out. Append it with a null. Set the null to be a color operator for the instances, and set channels to R, G, and B. It's a bit too dark. You can use a lookup top and a ramp to choose the colors. You can add some post-processing if you want. I'm just gonna do the basic feedback loop for trails, and that's already it. Now I want to talk about some things that might go wrong. So, here's the same setup. I've just saved it and reopened the project file. And for some weird reason, it's not working, although it did, just like a minute ago. Even if you hit init and start, it's not going to recover. I think the problem is somewhere in the flag stop, because now it gives me 128 by 128 resolution. And as you remember, we've set our sim to 10,000 points, so it should be 100 by 100. An easy solution for that is to insert a fit top right up to the flag stop and manually set it to the correct resolution. But now, if you change the number of points again, it's going to break again. And to avoid that, you can actually copy the fit top width, paste it as a reference to the number of points in our sprinkle top, and set it to the power of 2. So now you can control the number of particles with the fit tab. Hope you've learned a thing or two and enjoyed this little tutorial. If you have any questions, put them in the comments. Thanks again for being here and for your support, and I'll see you in the next one.